All right, class. We're going to go over lesson 3-2. This is on prime numbers and composite numbers. Numbers that are going to either the category of being a prime number or a composite number. We're talking about positive numbers here. So, prime numbers. How many of you are familiar with some prime numbers? Can you give us an example of a prime number? Devlin? Sorry.
11.
11. Yep, 11 is a prime number.
1.
1. Close. Actually not. 1 is kind of a special number because it doesn't have two factors. Okay? 1 is the only way you can make 1 by multiplying it with another whole number is just to multiply it by itself, right? So 1 is kind of special. Prime numbers have to have at least two factors. 1 and the number. 1 and itself. So 11 is a prime number because when you're multiplying to get 11, you can only use 1 times 11. That's the only way to make the number 11. Okay? Versus a number like 10. 10 is called a composite number because you can use different combinations of numbers to make the number 10 when multiplying. And we're always talking about multiplying here. Not adding, but multiplying. So, we can make the number 10 using 1 times 2 times 5. We could use 1 times 10. We could use 2 times 5. Are there any other combinations?
5 times 2.
5 times 2. So we can make the number 10 in different ways, right? That's why 10 is called a composite number. Okay? Any number that has more than two factors is called a composite number. Now, a factor. What's a factor? What is a factor?
Two or more numbers that when they're multiplied together make the number.
Make another number? Yeah. I want you to think of factors kind of like ingredients in the number. Okay? Or, how many of you like science? I love science. When you are in chemistry and you're making the molecule of something, you use elements, right? Elements make up compounds in science, right? You heard that before? Elements and compounds? Factors, prime factors like these, are like elements in science. 1, 2, and 5 are elements that you can use to make the compound 10. Okay? Or if you were making something like cookies. What's in cookies?
Cookie batter.
Yeah, but what's the batter made from?
Flour.
Flour. Chocolate chips.
Eggs. Chocolate chips.
Milk.
Vanilla.
Eggs.
There's no milk.
There's no milk in cookies? In some cookies, maybe.
In some.
Yeah, okay. There's different ways to make cookies, right?
Yeah.
But all of those ingredients, when you put them together, they make the cookie. Okay? That cookie is kind of like the compound. The things that go into the cookies are kind of like the factors. Factors make compounds. Okay? The numbers that make the other number. The factors that make the composite number are the factors of the number. Now, here are some factors of the number 32. 1 is a factor because 1 goes into 32. Actually, 1 is a factor of every other number other than 0. Okay. So 1, 2 is a factor. How do you find factors?
Like what we did here, you find
two numbers, does 4 go into 32?
Yes, that's right. We use the divisibility rules. Think about the number 32. Is 32 divisible by 2? Yep, because it ends in a 2. Is it divisible by 3?
No.
Why not?
Because 3 isn't even.
Well, no, what should we do to find the factors of 3? What do you have to do? Add the...
Digits?
Oh, come on, people, you know this. Add the what?
Digits!
Add the digits. What do you do?
Add the digits!
Yes, you have to add the digits. When you add the digits, what do the digits equal? What's the sum of the digits of 32?
5.
5. Is 5 divisible by 3?
No.
No, so 32 is not divisible by 3. Right?
Yeah.
Yeah. 4 is divisible by 3. Is 5 divisible by 3? Sorry. Is 32 divisible by 5?
No.
No, it has to end in a 0 or 5. Remember those rules we talked about yesterday and today?
Yes.
You use those rules to find the factors of a number. Okay? Now, if it has more than 2 factors, it's called composite. If it has only 2 factors, it's called prime. Okay? Here are some numbers that I want you to be familiar with. That's why I wanted you to write these down in a list. These numbers are called perfect squares. Okay? A perfect square is a number that is found by multiplying a factor times itself. So, 2 times 2 makes what? 4. So 4 is called a perfect square. 3 times 3 makes 9. 4 times 4 makes 16. 5 times 5 makes 25. 6 times 6? Yep. Now, what do, I'm missing one here. What do these numbers have in common? These highlighted numbers. Anyone know? They're perfect squares of prime numbers, exactly. They are all perfect squares of prime numbers. Look, 2 is a prime number because it only has 2 factors. Okay, this is cool stuff, people. Look up here. 2 has only 2 factors. 3 is a prime number, isn't it? 3 times 3 is 9. Is 4 a prime number? No, because how can you make 4? You can do 1 times 4 or 2 times 2, so that has 3 factors. 1, 2, and 4. So that's not a prime number. Is 5 a prime number?
Yes.
And 5 times 5 is 45. Is 6 a prime number? No, because you can make 6 with 1 and 6 or 2 and 3. Right? Is 7 a prime number?
Yes.
Yeah, and 7 times 7 is 49. Is 8? No. 9? No. 10? No. 11?
Yes.
Yeah. And 11 times 11 is 121. 13? Yeah, and 13 times 13 is 169. Okay? Now that's helpful to know because if you are asked this question, what is 169 a prime or composite number? Oops. Is this prime or composite?